So after completion of the zeros of the polynomial, now we are with the next topic, a relationship between zeros and coefficients of polynomial. So for giving you description, I am trying to start with the, suppose I am taking here the polynomial which is px is equals to x square minus 8x plus 15. हम इसका zeros of the polynomial निकालना चाहते हैं तो क्या करेंगे, इसको फैक्टराइज करेंगे. मिड टर्म स्प्लिट आपने किया है, एक्स स्क्वायर माइनस 5 प्लस 3x प्लस 15 एक्स स्क्वायर माइनस 5x माइनस 3x प्लस 15 एक्स कॉमन निकाल लेंगे, यहाँ पे हो जाएगा x माइनस 5 माइनस 3 x माइनस 5. So x minus 5 in one bracket and x minus 3 is in another bracket. If we want to find out the zeros of the polynomial, so we'll put here the 0 as it was given in definition also. So this is x is equals to 5 and 3. ये जो 5 and 3 है, this is denoted by a Greek word alpha and beta. So this alpha and beta, it is being presented in front of you. This is something new for you, but don't worry. This is something is a variables which we are using to denote the zeros of the polynomial. अब अगर अपने पास polynomial था तो zeros निकाल लिए. अब quadratic polynomial का फॉर्मूला होता है, quadratic polynomial के लिए अपने पास फॉर्मूला होता है. क्या फॉर्मूला होता है कि px इज इक्वल्स टू, अगर हमको quadratic polynomial बनाना हो तो px इज इक्वल्स टू एक्स स्क्वायर माइनस अल्फा प्लस बीटा इंटू एक्स प्लस अल्फा इंटू बीटा. इसका मतलब समझना आप, एक्स स्क्वायर माइनस सम ऑफ द जीरोज ऑफ द पॉलिनोमियल इंटू एक्स प्लस प्रोडक्ट ऑफ द जीरोज ऑफ द पॉलिनोमियल. जस्ट यू कैन check from taking here, suppose zeros of the polynomial we have, what are they? Suppose 5 and 3. So how we'll make the polynomial? X square minus 5 plus 3 into x plus 5 into 3. So this gives x square minus 15x plus, this is x square minus 8x plus 15. So you could see here, if it was given a polynomial x square minus 8x plus 15, it was very easy to find out the zeros of the polynomial, that it is being obtained 5 and 3, and if zeros of the polynomial 5 and 3 is given, we can just use this formula. So you know what is the general form of quadratic polynomial? That is, general form is what? Ax square plus bx plus c. You need to understand here this ax square plus bx plus c. What is the composition of this quadratic polynomial? This is in fact x square minus alpha plus beta into x plus alpha into beta. And we have some more formula. We have also the formula of sum of the zeros of the polynomial, means alpha plus beta is equals to minus b by a. What do you mean by b? Minus b, this is the coefficient of x. What do you mean by a? This is the coefficient of x square. So it could be written sum of the zeros of the polynomial. What would be the formula of the sum of the zeros of the polynomial? This is the minus the coefficient of x divided by coefficient of x square. And one more formula we have, that is alpha into beta. The formula for this we have c by a. What c stands for in the general form? C stands for constant and a stands for coefficient of x square. So this is all about exercise 2.2. One more thing you have, that is, I just will write here, although this cubic polynomial, it is not dealing on the large scale, just you should know about the cubic polynomial, the structure of the cubic polynomial, zeros of the cubic polynomial, and what is the relationship between. So this is, I am writing px is equals to ax cube plus bx square plus cx plus d. This is the format of cubic polynomial. And what is the formula to form the polynomial here? Cubic polynomial. The formula to form a cubic polynomial we have, this is, we have x square minus, it starts with x cube minus alpha plus beta plus gamma x square plus minus, again we'll have plus here it would be alpha beta plus beta gamma plus gamma alpha. Here third Greek word is being used because it has 3 0. So alpha beta, this is called gamma, this is called gamma, alpha beta gamma. Now this is the term of x, again minus alpha into beta into gamma. So this is a way to form the cubic polynomial. Although no questions it is given in the exercise on the basis of cubic polynomial, only one example it is given. So it is being assumed that very few questions to be asked from the cubic polynomial. So mostly you need to deal with the quadratic polynomial. So that's also. This is the sum of the zeros of the polynomial. Here the sum of the zeros being taken twice at a time, and this is the product of the zeros, right? And the same, if you will go to find out this alpha plus beta plus gamma, this is sum of the zeros, the formula is minus b by a, and alpha beta plus beta gamma plus gamma alpha, this gives you c by a. And one more thing we have here, that is alpha into beta into gamma, this is minus b by a. So as I said you, this is all about, this is all concepts being delivered, and now we are ready to start the next exercise, which is exercise 2.2. So we'll give you few examples and hopefully you all will do by yourself. So for exercise 2.2, what we have? For exercise 2.2, exercise 2.2. So the very first question is find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. You need to verify the relationship by using the formulas. That formula you all came to know. So the I am taking third part of the question number 1, or students would have probably with the problem with the fifth part. I am just taking the fifth part. The polynomial is given here, will like pt is equals to t square minus 15. So what is the first assignment? The first assignment is to find out the zero. For that what we need to do, we'll factorize this. So a square minus b square की formula में अगर हम इसको करेंगे तो ये t plus under root 15 in one bracket and t minus under root 15 is in another bracket. If we want to find out the zero, we put here 0. So t is equals to what? Minus root 15 and root 15. So this is we have alpha and this is we have beta. Now we need to verify. So what we are doing for the verifying, we'll write here alpha plus beta. The formula is minus b by a. Here alpha we have minus under root 15, beta we have under root 15, and what about the minus b by a? Here b part is not here. For b it should be the coefficient of t, but that is not here. So it means b is 0. So here we'll write 0 upon 1. So this is also 0, this is also 0. So this is verified. This is verified. Now this is the sum of the 0, and we need to do one thing more. What? Product of the 0. So alpha into beta. Formula is c by a. Now here alpha is minus root 15, beta is root 15, and what's the c in the given equation? This is minus 15 upon 1. So this is also minus 15, this is also minus 15. So this is verified. So this is the way to do the question. The rest of the questions you can do this pattern only. So do all the parts of the question 2.2, and now the second question. For second question, let me deal with the second question. What is the second question? What about the second question? So I am taking any one parts, I am taking the fifth parts of the question number second. So in this question you need to understand, you need to write very carefully. This is find a quadratic polynomial each with the given numbers as the sum and product of its zeros. Here it is given sum and the product. Suppose I am doing the question of what it is given. It is given alpha plus beta is equals to minus 1 by 4, and alpha into beta, this is given 1 by 4. So what we need to do? We need to form a polynomial. So the px is equals to x square minus 1 by 4 x plus 1 by 4. X square minus sum of the zeros of the polynomial and product of the zeros of the polynomial. So this gives us x square plus 1 by 4x plus 1 by 4. This gives 4x square plus x plus 1 upon 4. So this is 1 by 4 and this is 4x square plus x plus 1. So what is the required polynomial? This would be only the required polynomial. You need to understand these facts because we always take in. This is called the constant. So whenever we form a quadratic polynomial, we don't consider with the constant. We only consider with the ax square plus bx plus c part. So this is this one. So what is the required polynomial? We'll write here the required polynomial is equals to 4x square plus x plus 1. So this is something all about the exercise 2.2, all about this topic, and I hope you all would be completed exercise 2.2 by yourself. That's it.